Okay, so guys, in this video we are going to discuss the derivatives of exponential functions. Now, what are exponents? And let me just give you a basic idea upon an exponent. So if we are having something like 3 square, so square is known as the exponent. Okay, something which is present in a superscript is known as an exponent of the function. Okay, so what are the derivative of exponential function? Now there are different types of exponential functions. There are the basic functions, there is an Euler with a x, and there is an Euler with a function as exponent. Okay, so if you're having a basic function, a simple and very basic function with an exponent n, how you can find the derivative of it? You can simply separate the power, then you can write the function, and then again in the exponent you have to subtract the power by 1, and then you have to take the derivative of the function, the basic function which was given to you. After that, the derivative of Euler x, if the basic value of Euler is actually 2.71, but if you are having Euler and only x, now there is a difference between these two things, Euler x and Euler f of x. If you are having only x, okay, if you are having only Euler x, then the derivative of it would be Euler x, it would be as it is. But if you are having Euler f of x, i.e. you are having Euler function as a superscript, then you have to write Euler f of x as it is, and then you have to take the derivative of that function. Now what is the function? Let me just give you a very basic function. So y is equal to 3 of x. Now function is anything which is a mix of constants and variables. So you have a constant and you have a variable. Okay, so if you're having such a thing with an Euler and that function is present in the exponent, so you have to take its derivative too. Okay, now let me just give you a few examples. First of all, I have a function over here, Euler power x minus 1. Okay, so this is my exponent. Now, first of all, tell me, is it a function or is it only x? Because those are two different things. If you are having Euler, you have to concentrate on two different things. Either it's x or it is a function. Okay, so tell me, is this a function or is it only x? Now, this is basically a mix of variables and constants, right? We have the constant x and then we have a variable 1, and there's also a variable with this root over here. So it is very clear that this is a function, right? Now, okay, so we know that it is a function, this condition will be applied. Now how can I apply that condition? Let's just apply the derivatives on both sides of the equation, d by dx f of x and d by dx Euler x minus 1. Okay, so how can we represent the derivative? We can simply write f function single derivative. Okay, if you want to represent a single derivative, you can simply put a slash over it. Okay, then we have the function as it is. Okay, so we have Euler root of x minus 1. So this is my fx action. Then we have to take the derivative of this fx. So d by dx root of x minus 1. Okay, so I hope you get the point. Euler root of x minus 1, then d by dx x power 1 by 2 minus d by dx 1. Now I have just separated the derivatives on both of these terms, and then I have also written this square root as power 1 by 2. Okay, so those are two same things. Let me just separate it by a bracket because this is the basic function which we had. Then Euler root of x minus 1. We have a function with an exponent over it. So this condition right over here will be applied. We have a function with an exponent over here. The power will be separated 1 by 2, then the function, x is the function, then the power minus 1. So 1 by 2 minus 1 multiplied by the derivative of the function present right over here according to the condition. So the function we have is x, and the derivative of any constant is equal to 0, so minus 0. Okay, this dx will be cancelled by this dx right over here, and we are left with Euler root of x minus 1 divided by 2 x. Now 1 divided by 2 minus 1 will actually be equal to 2, 1 minus 2 minus 3 by 2, so we have negative 3 by 2. Okay, then Euler root of x minus 1 divided by 2. This x is present in the numerator, right? If I move it into the denominator, i.e. I'm reciprocating x, then this exponent right over here, this power will become positive, so I will have 3 by 2. Okay, so then we have Euler root of x minus 1 divided by 2 x 3 by 2. Okay, so this was actually 1 minus 2 is negative 1. I'm sorry about that. We have negative 1 right over here, and then this is 1 by 2, and then this is 1 by 2. So our final derivative is Euler root of x minus 1, okay, 1 divided by 2, x power 1 by 2. Okay, let me just give you one more example. So we have function is equal to x3 multiplied by Euler 1 by x. Okay, we also have the exponents right over here, and then these functions are being multiplied. Okay, let me just recall the method of finding the derivative of two functions which are being multiplied. Okay, so fx and gx are two functions which are being multiplied. So how can I write both of them? First of all, the first function as it is, derivative of the second function, plus the second function as it is, derivative of the first function. So this is the method by which we can find the derivative of two functions which are being multiplied. So over here, x cube is my fx, the first function, and then e power 1 by x is my gx, the second function. If we are comparing this thing right over here with this formula right over here. Okay, first of all, the first function as it is, i.e. x cube as it is, derivative of the second function, that is e power 1 by x. Okay, then the plus sign, gx, the second function, e power 1 by x multiplied by the derivative of fx. Now what is fx? X cube. So d by dx x cube. Okay, so let's continue. X cube. Now this is an Euler with an exponent 1 by x, right? 1 by x is actually a function, right? If we are having 1 by x, it is a function because 1 by x is containing both constants and numbers. We have seen equations like y is equal to 1 by x, which are actually representing functions. So e power 1 by x, according to the condition, multiplied by the derivative of this function right over here, 1 by x, plus Euler 1 by x multiplied by the power will be separated, the function as it is, power minus 1. Okay, then we have x cube, Euler 1 by x multiplied by, over here we can write it as x negative 1 plus Euler 1 by x 3x squared. Okay, so let's just continue solving it. Euler 1 by x multiplied by, now again the function, then the power. So the power as it is, function will be as it is, and then the power minus 1 plus Euler 1 by x 3x squared. Then we have x cube, Euler 1 by x. Let me just separate this negative sign right over here. Then we have x, negative 1 gives us negative 2. So this term is separated. Let me just put a bracket around it. Euler 1 by x, 3x squared. Okay, let me just write it in this form. Negative sign, Euler 1 by x dot x cube dot x negative 2 plus Euler 1 by x 3x squared. Now you can see this x and this x are matching, right? So the bases are same. Now when the bases are same, xm multiply xn, we can write it as xm plus n. When the bases are same, the powers are added. Okay, so I can write negative Euler 1 by x, x3 plus minus 2. So we have negative Euler 1 by x, x3 minus 2. Then we have negative Euler 1 by x, x3 minus 2 is 1. So 1. Okay, let me just remove the bracket. So we have Euler 1 by x multiplied by x with a negative sign plus present Euler 1 both by x, these terms, right? So I can take it out as common. So Euler 1 by x would be common, and also the x and the x are matching. Okay, only the first power is matching, not the second power. The highest power is squared, the lowest power is 1. We have to take out the lowest power as common. So let's just take out x common. Now we are left with, over here we are left with nothing, only 1 is remaining, negative 1, because if you see we have Euler 1 by x multiplied by x, and what did we take out common? It was Euler 1 by x divided by x. So Euler 1 by x multiplied by x. So these are cancelled and we are left with 1. Okay, plus if we see over here, Euler 1 by x plus multiplied by 3x squared, and the thing which we took out common was Euler 1 by x multiplied by x. So over here this one is cancelled and this is cancelled by the first power, so we are left with 3x. So we have 3x right over here, and I can rewrite this thing as Euler 1 by x, x 3x minus 1. Okay, so I hope you get the point of this video.